guys, what's up? So today we're going to be doing intro to limits. So limits are a really important concept in calculus. A limit is basically where a function is going. And these are really important to derivatives because derivatives deal with instantaneous rate of change. So as something is changing at that moment, how is it changing, right? A limit allows you to basically like travel on a graph and see where you're going on that graph. Okay? So a limit defined, it's this function, right? Where is it going as it approaches some value a, right? So the limit g of x as x, so this is the x-axis, approaches a is here and is on the y-axis, okay? So it's a way to represent like, like a, how do I say this? It's kind of like an output, right? If these are your function inputs and these are your function outputs, a limit is an output, right? So an easy way to kind of look at a limit is visually on a graph. So for a simple graph, you can just see, right? If we want to find the limit as x, right? X approaches. So this arrow here, this means approach in this scenario, okay? X approaches 1, right? It's asking us for this limit here as x approaches 1. So as we go on the graph, let's travel from this side. X is going to approach 1. We travel this way. Where are we? This is like 7. Equals 7. Travel from this side, we're going to get to the same spot, right? So basically, as you go on the graph and you converge to that point along the graph's value equals 7. So the answer to this, the limit is going to be 7. Okay, so this is the first example. It's a fairly simple example. If you would like, pause the video now and try this example on your own, and then repause or replay it when you want to see the solution. So over here, essentially what we do, it says evaluate the graph f of x to find the limit, and it's talking about this limit here. So the limit as x approaches, what's our x value? 1. And it's the limit of this function of x. Okay, so what we now have to do is we go approach the function from here, this way, and where do we go? This is about -5, -4, -5, -6. This way, where do we get? That's also this point, -5. This is 1. So at the value of 1, it's about -5. Okay? So that's the answer to this limit. So we looked here evaluating limits using a graph, right? And we're just saying where's the limit, right? What is the limit and where's the limit? So you notice we were going from one side and from the other side. So we can just evaluate from one side or the other side as well. We can approach limits from both the left side and the right side. Right side, the positive side, and the left side, the negative side, right? So imagine traveling along one side of the graph. Where do you end up? Over here, we traveled along one side of the graph. There's another color. Traveled along one side of the graph this way, we ended up here. One side of the graph this way. To this point, we ended up here. Okay? You're basically like, this is your limit from the right, limit from the left. We're going closer together. Okay? As we travel to our chosen point, arbitrary point, we can evaluate from either side where we're going. Because remember, we're traveling to an x coordinate, right? So the y coordinate, we're just seeing where we end up on the y coordinate, right? So let's try this example. So here it's asking us to find the limit as x approaches -2 from the positive side. So this is the positive side, right? The right side is the positive side, technically. Right? You can say right, positive. Like, it's kind of like a, oh, you're right. Yeah, that's a positive thing to be right and a negative thing to be left, I guess. I don't know. But, so we're traveling from the right side as x approaches -2. So -2 is here. So we can highlight this line. We're going to go here. So as we travel this way, where do we end up? Here at -4. So we can say the limit as x approaches -2 from the right side is going to be equal to -4. Now, what about the limit as x approaches -2 from the left side? Notice the negative sign. So as we approach this way from the left side, we're approaching from the left to x equals -2 here. What's our value? Our value here is -7, right? So the limit as x approaches -2 from the left side equals -7. Okay, pause the video here and try this one on your own. I want you to find the limit as x approaches -4 from the left side and the limit as my pencil is not working, x approaches -4, or sorry, 4, just 4, from the right side. From both sides, I want you to find the limit as x kind of goes to this line. X equals 4. Okay, pause the video, try it, and then replay the video when you're ready to see the solution. So, limit of f of x as x approaches 4 from the left. So we move along the graph from the left this way. Where do we end up? This point that we reach at the line is at 4. So the limit is going to be 4. We move along. Now we're going to do the right side. Limit as x approaches 4 from the right side, f of x equals. Okay, let's see what the limit of f of x as x approaches 4 from the right side is. So we're going to travel along this path. And as we get to 4, where are we? We're at 3 on the y-axis. So the limit of f of x as x goes to 4 from the right side is 3. Okay? So with limits, there's a thing called existence. How do we know a limit exists? So over here, this limit exists and this limit exists. But what about the limit of the whole function, right? What about the limit of f of x as x approaches 4, not from the left to right, just generally? So when we say it as x approaches 4, remember we said from both sides. So the main criteria for the existence of a limit is the left-hand limit exists, the right-hand limit exists, and the left-hand and right-hand limits are equal, right? Criteria, existence, uniqueness, finite. We don't have to worry about this one for now, but continuity matters we'll see later on in this course why continuity matters for existence of a limit. Okay? So if a limit exists, its left-hand and right-hand side are equal. This is a good enough definition for now for the existence of a limit. In this scenario, this limit as x approaches a exists because from the left and from the right, you'll end up in the same place. Okay? Okay. Pretty much, if you're on your function, you're going like this, wherever you're going this way, if both sides meet in the same point, then the limit at that point exists. That's the existence of a limit. For a right-hand and left-hand limit to exist, it just needs to evaluate to a number. if a limit evaluates, so basically if your limit goes to infinity, for example, if you draw a graph like this and you say, what's the limit approaching the y-axis, approaching limit of f of x as x approaches 0, it's an asymptote, right? So it's going to go all the way up. Maybe in your pre-calculus class you learned about asymptotes. It's going to go all the way up. If the limit goes all the way up, it never, like, there's not a finite value, then that limit can't exist. Okay? That's the finite. Uniqueness is where you can't have two limits at the same spot. So over here, for example, this limit, d and e, if the whole function, it doesn't exist. Because from the right side, it's 3, and the left side, it's 4. So it's not unique. Can't exist. And existence is, both sides have to exist. If this is infinite, then, and this is 3, can't exist, right? So either scenario of the 3, they basically both have to be the same. If they're both infinity, it doesn't exist. That's the only exception. If they're both infinity, then the limit doesn't exist. Because if it's infinity, it doesn't exist. It needs to be finite. It needs to be the same finite number that they're approaching. Okay? So for an example of both being infinity, if this function goes down like that, we'll see this when we get to more rational functions, and we're going to explain more about a limit going to infinity in a future lesson. But it's important to understand this a little bit. Basically, if this limit goes to negative infinity and this goes to infinity, then this limit doesn't exist. If this one goes to infinity and this one goes to infinity, it still doesn't exist because both are not finite. Okay? So you need to meet on both sides at a real finite number. If it's an infinite number, no, it's not. It can't go to infinity. The limit does not exist. Okay? So try this example. Does the limit as x approaches 3 exist for this function f of x? So pause the video, try it, and then replay when you're ready. Okay, so what do we need to see? We need to see the left side limit. And right side limit. Okay. Go to a different color. Limit as x approaches what? As x approaches 3. From the right side. What's that? We'll go from the right side. We'll go this way. And we'll approach it. And what do we get? It's 5. Limit as x approaches 3 from the left side. That's also going to be, we're going to go across the function like that and get to 5. That's what's that. It's also 5. Right? So, therefore, it's a finite number, right? It's unique. There's only one limit. It's both approaching, and both limits exist from both sides. So therefore, the limit x approaches 3, f of x, exists and equals 5. In math, therefore statements are very important. You have to include therefore statements to get full marks. Usually, most schools will take off a mark, or sometimes 2 marks, if you don't include a therefore statement. So these syntax errors are really important. There's a difference between like 80 and a 90 or 70 and an 80. Is these kind of notation. Okay, let's try this question. Example 5. Does the limit f of x exist? Okay. So, as x approaches, let's be careful here. It says as x approaches -1. So as x approaches -1, from the left side and from the right side, they both converge at 8. So 8 is unique, 8 is finite, and both limits from both sides exist. So yes. Right? What about this one? As x approaches -1, does the limit exist? So as x approaches -1 from the left, you get -6. As it approaches from the right, we get -3. So no, both are finite, yes. Their limit exists for both sides, yes, but they're not unique. So it's because they're not unique, there's two. They don't go to the same point. Instead of hitting each other, you miss each other. So the limit does not exist. For the function f of x as x approaches -1. Okay, hope you guys enjoyed the video. Catch you next time for the next lesson on limits. Bye.